Okay, number 9. Correctly organize the following transformations into those that always preserve congruence and those that may not always preserve congruence. So the ones that always preserve congruence, or they keep, preserve is another word for keep, congruence, same size. So think about those 4 transformations. We've got rotation, reflection, translation, and dilation. So which of those always keep the same size shape after they're transformed? So we should have translation is one, because all we do is we slide it. Reflection is one, because all we do is flip it over one of the axes. And rotation is one. So all of those transformations, they're going to keep the same size, the same shape. They're just moving about the coordinate plane. So then the ones that may not always keep the same size and shape. There's only one left. Dilation. Dilation changes the size always. So dilation will not preserve the congruence. Number 10. A rectangle is located on a coordinate plane if the ordered pair x and y represents a vertex of this rectangle, which algebraic representation describes the effect of translating the rectangle 6 units down and 4 units to the right. So this is what I was talking about. Sometimes they'll give them to you, they won't give you x first, they may give you y first. So that 6, that's talking about your y-axis. And if we go down on the y-axis, those are our negative numbers. And then the 4 units to the right, so right and left, that's talking about your x-axis. If we go to the right, that's our positive numbers. So we should have something like x plus 4 and y minus 6, which should be D. Number 11, quadrilateral. ABCD is shown below. If ABCD is transformed to create A prime, B prime, C prime, D prime, and the coordinates of the rectangle are A prime, B prime, C prime, D prime, A, x negative y, B, x negative y, C, all the same. So what's the only thing that's changing on these coordinates? They're staying in the same order, so we know it's probably not a rotation. The only thing that's changing is our y, the sign in front of our y is changing. So it's not going to be a translation because that would be adding or subtracting. It's not going to be a rotation of 90 degrees because they didn't flip-flop places. That would mean there was y and then x. So it's either got to be a reflection across the x-axis or a reflection across the y. X. Remember, it's always the opposite. Whatever axes it's flipping over, it's changing that opposite coordinate. So reflection across the x-axis. Number 12, if triangle ABC is rotated 270 counterclockwise about the origin to create A prime, B prime, C prime, if point B of ABC is regular AB, kind of like X and Y, which algebraic representation best represents B prime of ABC. So, and like I said, I'm going to leave all those rules up, but the rule for 270 counterclockwise is the same as 90 clockwise, which would be X and Y, and they flip places, and then your second number becomes negative. So since we know that they flip, so we should have B first, we could go ahead and eliminate C and D, because we know we need to have B first since they flipped. So then between A and B, it's got to be A. The sign in front of that second number changes. Rectangle WXYZ was dilated to form ABC, shown below. So WXYZ was dilated, so that's our old image, or the pre-image. And ABCD is our new. So what's the relationship between the area of rectangle ABCD and rectangle WXYZ? So since we're looking for area, we're gonna multiply our side lengths, our base times height. So the old area, we wanna multiply 3.6 times 9. So you should get 32.4 for the area of our old. Then for the new, same thing. We're gonna find our new area. So 1.2 times 3. And that should be 3.6. So then to get that scale factor to see what the difference is, divide new by your old. So that new number, that new area was 3.6 divided by 32.4. That should give you 3.6 divided by 32.4. Check one more time. Make sure you put 3.6 in first. Good, 0.111. If you, and so our answer choices are in fraction form, so you can hit that math fraction button and it'll change it for you. Good, so it should pop up to be 1/9. So A would be our answer. And on this one, since it got smaller, we can see that it got smaller. So you could have already gotten rid of C and D, since it's basically saying that they got bigger. Number 14, Sebastian is building a pool in his backyard as shown below. If Sebastian increases, so he's making them bigger, the length and the width of the pool by a scale factor of 3, what will be the resulting effect on the perimeter of the new pool? So we did this on our page the other day. So since you don't have any numbers, a lot of times it helps to create your own numbers. So you can make a new width and a new length and then solve from there. So if we use 3 for the width and 6 for the length, and then we multiply that width and length by our scale factor to get our new picture. So I can multiply my width 3 times 3, so my new width would be 9. The length times 3, so 6 times 3.
18.
Good. Then the perimeter. So the perimeter of my old and the perimeter of my new. So perimeter of the old, add 6 plus 6 plus 3 plus 3. Add them all up together.
18.
Should be 18. Then perimeter of the new. So 18 plus 18 plus 9 plus 9.
54.
50 what?
4.
54. So then to get that scale factor, divide your new perimeter by your old perimeter. So 54 divided by 18.
30.
Good. So the perimeter, A says it'll be 6 times, B says it'll be 3 times. So that's the answer we got. So it should be B, and that's the same thing on this one. You could have gone ahead and eliminated C and D since we saw that it got bigger, or he increased it.